Hey, welcome to a video on Chapter 6 Introduction. This will be Tuesday's notes for those of you who were gone on Tuesday, April 9th. Most of you were gone for track. If you're in that boat, you should be following through with this lesson. You should have your notebook out and your periodic table out. With this screencast app that I have here from Google, I'm allowed 10 minutes. So I'm going to ask you several times to pause the video and do some things for me. And I'll just continue on. So when you're done doing the task, then you can hit play again and follow along. So that'll just save me time here on my screencast app. So chapter 6 gets into chemical formulas, chemical stability, chemical bonding. Today, the most important thing to understand is why atoms form chemical bonds. So we're going to talk about that as we go through here. So what I'd say, first of all, this first slide, just sort of an introduction piece. We've talked about all this before. Important things here is that there are very few elements that exist uncombined in nature, only a few of them. On the whole periodic table, that's 118 elements. Only really the noble gases exist uncombined. So helium, neon, argon, krypton, xenon, radon, they exist by themselves uncombined in nature. A few others, gold, silver, copper, titanium, but most other ones don't exist by themselves. You won't find an atom of sodium in nature. Okay, it's always going to be bonded with something else. Well, why is that? It has to do with stability, okay, and chemical stability. So we'll talk about that today. And because of instability, they form compounds with other elements, and their properties then change. So if you want to pause it and write this stuff down, you certainly can do that. Not all that important, I wouldn't think, though. So I'm going to move on to the next slide. So one important thing in this chapter is understanding what a chemical formula is. And a chemical formula basically talks about a compound. So H2O is a chemical formula. Okay, it represents the atoms and the number of each atom in water, right? So it's got a number ratio there. So that little 2 is a subscript. Okay, the subscript is the number written underneath in these compounds or chemical formulas here. Okay, and it tells you how many of each atom there are. So in water, in H2O, that H2 means there's 2 hydrogens. The O means there's 1 oxygen. So if I was going to summarize this slide for you, what I would do is write down chemical formula. I'd write down H2O right behind that, because H2O is a chemical formula. I'd put an arrow to the 2 with the word subscript. So you know that 2 is a subscript, and I'd write down that there are 2 hydrogens and 1 oxygen in that chemical formula. So that's an important thing for this chapter. The most important thing for today, though, is understanding chemical stability. So an atom is chemically stable when its outer energy level contains 8 electrons. This is a really important thing to write down. Probably one of the most important statements of this entire chapter is understanding that when an atom has 8 valence electrons, it is chemically stable. Okay, so I'm going to give you a second to write that down. Pause it, write that down, come back. Okay, I'm assuming you have that written down by now. And all these noble gases have 8 valence electrons and are stable. And because of that, they don't form compounds. Okay, they all have 8, except for helium. But helium's happy with only 2, because 2 makes a full first energy level. So helium is an exception because it has 2 valence electrons, which makes a full first energy level, which makes it happy. Almost every other atom on the whole periodic table wants to have 8, so that number 8 is important. Remember that number 8. We want to get to 8. All right. So to truly understand chemical stability, I want you to draw the Bohr model for sodium. So why don't you in your notes right now and take out your periodic table and draw a Bohr model of sodium. Hit pause and do that right now. Okay, so I am assuming not by now that you have the Bohr model for sodium drawn, and mine's being dumb. For some reason, it's coming up later. So if you look at sodium, you can see that sodium has 1 valence electron. Is it happy with 1 valence electron? No, it absolutely is not happy. In fact, sodium is freaking out. It is freaking out, man, because it wants to have 8 electrons in its outer level, and it only has 1. It's freaking out, can't handle it. Okay, so 2 things that sodium can do to become happy or stable. It can either gain 7 electrons out there. If you put 7 more electrons around the outside, then it's happy, right? It's got 8. Okay, or it can lose that electron. If it loses this 1 electron, then it is also stable because it has 8 in its outer shell. Because this shell now has 8. 1, 2, 3, 4, 5, 6, 7, 8. It's good. So I'd be happy that way. Either gain 7, lose 1. Which one seems easier? Well, obviously losing 1. Losing 1 electron seems to be the easier thing to do. It's less to do, so we'll try to lose that 1. Problem is, sodium can't just drop that electron and run away. It's illegal. Can't do that. So what's it going to do? All right. Now I want you to pause the video again and draw a Bohr model for chlorine in your notes. So take out your periodic table again, draw a Bohr model for chlorine. Okay, so I'm assuming you have this done by now. You drew chlorine. You can see it right here. Is chlorine happy? Well, if you're looking at your Bohr model, you counted 1, 2, 3, 4, 5, 6, 7 valence electrons. So chlorine is not happy. It wants to have 8, not happy with 7. Okay, so what can chlorine do to get to 8, an octet of electrons? What can chlorine do to get to 8? What do you think, Menz? You with me, Menz? Kate? Catherine? Others? Well, it can either gain 1 electron and get to 8, or it can lose 7 electrons. Obviously, what's easier? Gaining 1 electron. And maybe you're getting ahead of the ball game here and you see, oh, I know where it's going to get that 1 electron from. It's going to probably get it from sodium, and that's absolutely what happens. So if I go here to, I have pictures of these 2 Bohr models prepared. Okay, so we have sodium, we have chlorine. Okay, sodium, not happy, has 1 valence. Chlorine, not happy, has 7 valence. So here's what is going to happen. This electron from sodium is going to travel over and take that place right there on chlorine. Why did it go away? It went away. So that electron is going to go there and stay there. Okay, sodium is going to give the electron to chlorine. And if that does happen, then sodium now has gotten rid of that 1, and it has 1, 2, 3, 4, 5, 6, 7, 8. Sodium has 8 electrons. Is sodium now happy? Yes, sodium is happy with 8. Good. Chlorine now has 1, 2, 3, 4, 5, 6, 7, 8 in its outer shell. Is chlorine happy? Yes, chlorine is happy. Therefore, they are both happy. They are both stable. Notice, see, happy. It's happy. And they have formed what's called a chemical bond. They have formed the bond sodium chloride, Na. Wow, I'm really bad at this. Cl. Where'd my A go? Where'd my L go? Come on. Whatever. NaCl. We get it. That's frustrating me. Come on. Nice. So it's formed NaCl, sodium chloride. So the thing about this is sodium has given up this electron. It can't just run away from chlorine and go away and be gone and be happy forever. Can't do that. Because it gave up that electron, it is now stuck to chlorine forever in a chemical bond in this formula sodium chloride. But it's happy, it's stable that way, and chlorine is happy and stable that way. So we have formed what's called a chemical bond. So the last thing I want you to do is just describe for yourself what a chemical bond is. So we've learned today that to achieve an octet of electrons, or to get to 8 electrons, atoms form chemical bonds with other atoms. Okay? And that chemical bond is an electrical force that holds atoms together in a substance, kind of like 2 magnets, right? One gives up an electron, one gains an electron, and now they're stuck together in a chemical bond. Okay? And the last thing to write down is that chemical bonds can form in 3 ways. And this is a test question. Kate, remember, test questions, you like these. And the test question will be, what 3 ways can atoms form chemical bonds? Well, they can either gain, lose, or share electrons. So write that down, move on to the next video. Great job. How do I stop this? How do I stop this madness? Oh, right here. Hold on. Let me try to make this shot. And, oh, that was awful. Make my cat also awful. Okay, bye.